This week we're going to talk about the sound department and how it works with the rest of the crew in the making of a movie. With the hierarchy on the set, the sound department falls under the auspices of the cinematographer as well as the gaffer and key grip. On set, there are usually two sound people, and sometimes three, the mixer and the boom. The mixer is the person who takes in the sound signal from the microphone, which is held by the boom operator, and sometimes there's a utility cable which helps attach some of the cabling from the mixer to the boom to the sound card to the camera. Once the sound is recorded by the mixer from the mic, it's put in a sound file, digital sound file, and that sound file is then handed off to the supervising sound editor, who in post-production has a team of people who adjusts everything for the final mix. They have a dialogue editor who decides which dialogue is really necessary for the final cut and which dialogue doesn't work, so that they might have to replace it with new dialogue that's better recorded, because maybe the old dialogue, the two actors stepped on each other's lines, or maybe there's some background noise that interfere with the dialogue, so they have to re-record it. So they do that with what they call automated dialogue replacement, and they have an ADR editor, because it's called ADR, who then gets the actors to come into the studio where they re-record their conversation by looking at the rough cut of their acting and matching the sound to their lips moving. There's a backgrounds editor who will take the ambient noise, the surrounding noise, and adjust the background noise that makes it realistic. The birds or the wind or whatever scene is important as far as sound goes. They make sure that the sound doesn't overwhelm the scene, but adds a realistic context to the scene. So then we have the sound effects editor, who then adds those special sound effects, the thunder, the lightning, the booms, the crashes, the dramatic stuff, and the Foley artist, as we saw a couple of weeks ago, adding the footsteps and the crunching of the gravel and the turning on the switches, all those clicks and crunches and footsteps. The Foley artist is doing that. Finally, the music editor is applying the soundtrack, and we call them usually the sound designer. All these people work together, and they combine everything with the sound designer, and the re-recording mixer then re-records all this together, and we get the soundtrack for the movie. Here we have a sound team on set. The gentleman to the right is the boom operator. He's got the boom pole in his left hand. He's got a mixer between his legs. He is standing next to the woman who's probably the mixer herself. They're both on headset, waiting for their signal to go to set. And in the middle we have a mixing board and a sound recorder above that. And that's the sound cart. And behind the sound card is probably a utility tech, a utility sound tech. Here we have a sound mixer on set. Remember, the head of the sound department on the set is the sound mixer. She is head of the rest of the team. She gives the orders to the boom operator and to the utility tech. She's the one in charge. She has a mixer here below with the levels for adjustment, and then she has a recorder up there, a digital recorder, taking the signals you can see on the left coming from the microphone and the camera. So she'll be adjusting the levels and recording on the digital file. Notice that she's got this steel dot to the left here with this strange stand holding it, and but there's a bunch of grip clips. I see grip clips everywhere. We got grip clips, some cables. Well, that's because the sound cart isn't taken to the set by this mixer or the boom operator. The sound cart, which we see here on the left next to the continuity cart, is taken to set by the grips. So if there's anything that needs to be attached to that sound cart, it looks like it was put together by grips, because they are the ones who do the heavy lifting when it comes to moving that material. Here we have a mixer on set. He's got the headset on. He's got his mixer in front of him. He's got above the mixer a digital recorder. He's got all the cabling, the XLR cabling going out to the camera you can see on the left there. So he's got a feed to the camera, and he's got a feed to the boom, which is still on the cart, because they're in pre-production here. They haven't quite got to recording. We have signals coming from the camera and the boom in the mixer, and we'll talk about it later, but this is because we want to make sure that we have two tracks in case for some reason the mixer doesn't get the main mic. It can get the camera mic as a backup recording. And when the camera mic, which isn't the essential recording because it's not as sophisticated and as narrow in focus as the boom mic, that camera mic we call the scratch track. If we're going to get sound recorded on camera, it's a scratch track, it's a backup track. Here we have a boom operator or a mixer. We know he's in the sound department. He's got cans on, he's got his headset on, always listening to levels and what's coming in. Here we have a boom operator on set. We can see his cans are on, his headset's on, he's got the boom out. Notice the cord on the outside of the boom. The boom is just a long pole that has a cord that takes the electrical signal from the mic back to the mixer. We like the cord on the outside of the pole because if you put it in, it will pick up the sound of the cord inside the pole, and you'll get some rattling sound on your recording. You don't want that. Here's a boom operator indoors recording sound. Let's talk about sound waves. We'll just real quickly over the theory of, just like the theory of light. Sound is merely waves that our ear takes in, and same thing with the mic. So here's a gentleman emitting sound waves, and we can just see it here. And this speaker is like, this speaker cone produces sound waves by vibrating surrounding air molecules in fast rhythmic bursts of energy. And this we have in waves are in particles, just like light, and the frequency of those waves distinguishes between the high and low sound that we hear and the intensity of the sound coming that is recorded. So we worry about frequencies being too high when we record because it'll clip out on a recording, it'll just pop, and too low so as we can't hear it. As with light, again, dealing with waves again, remember that inverse square rule. We have a similar thing with sound, where the sound velocity falls as we go and double the distance, and it goes by a inverse squared. It depletes rapidly. What happens is the wavelengths, the frequency, dissipate, become less intense, less frequent, and so over distance, sound decreases. You get better sound up close. Here, very simple. We can see that if you want good sound, you have to be really close, relative distance to where the mic is. The farther away you are from the mic, the worse sound. And so this is what I need to convey to you. Here is a omnidirectional mic, and I want to say that when you record sound, the only difference between good sound and bad sound when we record it is the positioning of the mic. It isn't the expense you've paid for the high quality microphone. It's how far that microphone is from the sound source. You can have a very expensive mic and be 10 feet away from somebody talking, and it's not going to record as good sound as a cheaper mic 6 inches away from the person you're recording. So it's not the quality or the expense of the instrument, it's the distance that mic is from the sound being recorded. So that omnidirectional mic, we call it that because the pattern of sound waves coming in are 360 degree, kind of equidistant. They're coming in a circular pattern and being recorded. So it's getting all that background ambient noise. And usually when we have those, we always have the speaker get close to it, because that way the loudness of the voice will drown out the ambient noise. Here we have a stereo pattern. If you have these two crossed, you can see we cross those two mics, and what happens? We've got an egg-shaped pattern in the middle, and so that means that they're canceling out different phases of waves so that it narrows the sound and the focus of the sound, and you don't get so much background sound. So what we like is that pattern. You can see that shotgun polar pattern in the mic to the right, the shotgun mic. That means if we record with a mic like that, it's not going to get the frequencies on the surrounding sides. It's going to just get it coming in from where it's pointed. And so these are the kind of mics you're going to see on a movie set. So if you have an omnidirectional pattern and a cardioid pattern, hypercardioid shotgun, or cardioid mics are just a smaller shotgun, a smaller mic. It's taking in a pattern, as you can see, a heart-shaped pattern and a little less heart-shaped pattern. It's very sensitive, and it's taking in a narrow frame of sound, but it's not canceling out all the phases. So it's the frequencies on the side are coming in. This is good if you're indoors and you want good tones to the way they're talking, because when people talk, if you just narrow the straight on, sometimes you don't get that plummy sense of the whole richness of the way they talk. And you can see the shotgun is on the left, and it's getting a narrower focus to what's going on. So here is your basic boom set for a movie when it comes to mics. You've got your fuzzy Wookiee on the bottom, which we'll talk about in a minute, and you got a handle down above the Wookiee, which is kind of like a pistol handle. But your main thing is your boom pole there, which has 3 phases that can be stretched out. And you notice there's the electrical cord that in this case is in the boom pole. It's carbon fiber, so it doesn't rattle that much. It doesn't pick up that much sound. And at the end of that boom pole, you've got the XLR connector that would go into the mixer. Now, the boom pole, remember, the boom pole's got batteries in it because that's what has to take in the sound. It has to be electrical charge to take in those waves. And so we have AA batteries in the boom pole, and then we'll go into the mixer, which also has batteries. But to get good sound on a set, we supplement the power of the batteries in the boom pole with power from the camera. So if we're running power from the boom pole into the camera and the camera out to the mixer, we have the energy that's running the camera also helping boost the electrical signal inside the boom pole. We call that phantom power. It's a setting on the camera, phantom power. So if you have phantom power on, you get a better signal. Sometimes people sit on the set and say, well, I just lost power. Well, someone turned off the phantom power in the camera, didn't get it that extra boost. Okay, the 2 mics we see there, we have a cardioid mic right next to the boom pole, which is just a shorter mic, but very sensitive, just has a wider input of frequency sound waves. And then we have the shotgun mic. You see all those slits on the side? Those slits are made so that when the waves come in, they come in at different phases, different levels, so they don't cancel each other out, but they cancel in a scale different waves out, so that it will get a cleaner sound where that mic is pointed. So here's the difference: the hypercardioid and the shotgun mic and sizes. And you can see the interference too, what I just talked about, where the phases are canceled out, so you don't get that whole surrounding. You just get that narrow throw of the shotgun. And you can see here in the patterns that we draw on the blue, green, red. The red is a shotgun mic. You can see the pattern of waves coming in is a narrower pattern than the cardioid. So if I'm pointing that mic at somebody, I'm going to really get clean sound and not worry about that side frequency that's going on. Here's an example of the cardioid, where we not only have a wider frequency area of sound coming in on the sides, but in the back of the mic we also have this kind of bulge out there. So it's not only getting sound in front and around the camera, but also from the rear of the boom pole. So it's going to maybe pick up some background sound. If you're outside, this could be dangerous for your recording. Here's a shotgun mic coming at you. Now, a shotgun is a long cylindrical microphone that excels at picking up sounds in front of it, while rejecting sounds to the sides and the rear, like we just saw on the cardioid. Shotguns are designed to have a narrower focus than on an average microphone. So they're really good at picking up frequencies that the human voice picks up, okay? So they're usually used when you cannot position a mic directly in front of the sound source, which we usually can in a movie because they would get in the way of the shot. And here's that nice polar diagram of the shotgun mic. You can see it's really got the narrow focus. It will pick up a little in the rear, but not as wide a bulge as we get in the cardioid, so it's safer outside.